Good morning. This lesson is about dimensioning our multi-view drawings. So we've been working on orthographic multi-view drawings, and now we want to talk about how we dimension them. So dimensions, if you're not sure what that means exactly, when we talk about dimensions of a figure, we're talking about the measurements. And so if I were talking about the dimensions of a rectangle, that would typically mean the length and the width. If you're talking about the dimensions of a circle, that usually means the diameter or the radius dictates how big the circle is. So when we talk about dimensioning, we're talking about assigning specific measurements to the drawings that we've made. This lesson is adapted from activity 1.2.4 in the PLTW curriculum. So let's talk about what dimensioning is as a process. It says, although multi-views are drawn to scale, you often cannot obtain exact size and location information about an object by measuring a drawing. Dimensions provide exact size and location measurements for the features of an object so that the object can be built precisely as designed. So we're talking in terms of actually manufacturing and building an object. We know what it is to draw things to scale, and we can take our ruler and we can put our ruler up next to it, but we know that there are limits to how precise we can measure something, how accurate our measurements can be with a ruler. If your hand even slides a little bit, your measurement will be off. And so we don't want to rely on that. Adding dimensions to a drawing often requires following prescribed international employer and/or client standards. So that means that you cannot just decide willy-nilly how you want to measure something and what kind of measurements you feel like providing. Whether it's your employer or your client, the person who is you're doing the design for, they are going to want things dimensioned in particular ways. Standards provide guidance for fundamental dimensioning practice. Throughout this course, you will use dimensioning guidelines as your standards. So when you're dimensioning something, there are specific requirements that you will need to follow. So let's take a look at a couple more line types. In the last lesson, we talked about center lines, hidden lines, construction lines, and object lines. Once you start dimensioning, we actually have a couple more lines that we need to talk about, and it's super, super small on my computer screen right now. So let's talk about a dimension line. Dimension lines are these lines here. They have arrows at either end, and the measurement is located in the middle of them, indicating the dimension or size of whatever you're measuring there. And so we see a dimension line there. Now there's some other lines there. We have here, I want to keep using the blue, what's called an extension line. So we don't write the dimensions on the figure itself. If you look closely at these, none of the dimensions are written on the actual figure. They're all written outside the figure. We don't want to clutter up our drawings by writing numbers and having these lines. But you can't write all the measurements like on top of each other. And so what we have here is what's called an extension line, and it shows you where you're dimensioning to. So we're dimensioning from this side here to this side right here. And these extension lines, if you follow where my pointer is there, kind of extend the sides of the object upwards so that you can see what you're dimensioning. And you've probably used those before, you just didn't know that that's what they were called. Now, hidden lines and center lines, we've seen those before, okay? And that's from, if you can see the circle over here that I just circled on the isometric, that's what you're seeing. When you're looking at it from the front, you can't see that there's a hole drilled in this somehow, and so you're seeing those hidden lines and the center lines. A leader line is one of these lines that usually is when you're pointing like to a circle or some feature like that, maybe like a fillet on the edge of a drawing. And it points to what you're measuring, okay? So that's called a leader line. We've already covered object lines and we've already covered center marks. Some important details here when dimensioning circles and arcs. There's some symbols here. Use a center mark and center lines to indicate the center of the circle or the arc to locate the feature. We have done that before, so we talked about that last class. You need to indicate where the center of the circle is. And then you have a couple of symbols. So this symbol I'm drawing over on the left-hand side of your screen there is used to represent the diameter of a circle. It's kind of like doing the diameter like that. But I don't know if you're hearing the cat. He really, really wants to learn about dimensioning guidelines, but I don't think he's at that level yet. It's like taking the diameter and you just kind of extend it a little bit more. It looks a lot like the Greek letter phi or phi. Now it looks like I drew the same thing 3 times on the side there. And then you use a capital R to indicate the radius of an arc. Circles are always dimensioned by their diameter and arcs are always dimensioned by their radius. So here on this one, you'll notice that you've got the line going to the edge of the circle, and then you have the symbol for the diameter indicating what the diameter of that circle should be. So this year, this is new to PLTW. They presented this material differently last year. They have what's called a dimensioning flowchart. So you may or may not have seen a flowchart before. A flowchart is a chart that indicates the flow of a process. And so it has different shaped boxes. If you ever study computer programming, you will do lots of flowcharts for it. And that's like programming in any kind of language here. So you have your beginning and you have your end, and those are usually indicated by ovals for your start and your end. And then you have these rectangular boxes that tell you what to do, and they're connected by these arrows, and diamond-shaped boxes are what are called decision boxes. And that's where you have to ask yourself a question, and your decision boxes, if you look at this, they always have more than one option depending on what you decide. And so the arrows tell you where to go, and if you follow the flow chart, you should go from the beginning down to the end. So the process is something like this. You can create a complete multi-view drawing. So we've spent the last several class periods working on our multi-views. Then you count the number of features. Now, features mean something very specific when we're talking about the design process, but features would be things like holes, fillets. We haven't done filleting yet. Filleting is when you take like a sharp corner, like the edge of my notepad here, and you were to make it rounded with a kind of arc. Okay, and you would actually specify it by the radius of that arc. So it'd be like having nice round note paper instead of boxy right angles. Yeah, so those are like your features. Next, you select the best view. I'm right here on our flowchart. Select the best view to represent each feature. So when you have these different features, there are some views that are going to show those features better, and you want to dimension them on the view that best shows the feature. So with the example on the previous slide, you couldn't see the hole from the front. You could see the hole from the right-hand side, so you dimension it on the right-hand view. Then dimension each feature, its size and its location. So you don't want to just dimension the diameter of the hole. You also need to locate the hole on the face, which means you might have to give the distance of the center from, like, say, the left side and the top side, and that would give you where the center of the hole is, and then you need to dimension the hole itself. So what's the diameter of it? Then you ask yourself a question here. So we get to this decision box. Every feature fully dimensioned, size and location. To make that a question, we should probably put the word is up there, which of course I did really sloppy. Is every feature fully dimensioned with size and location? That's kind of a check. You stop, you check, you look back at your work. If the answer is no, you realize, oh wait, there's this other feature that I haven't dimensioned. Then you have to go back up in your flow chart and you have to select the best view for that feature. And eventually you come back down here. Hopefully you'll say yes, at least eventually. Like, yes, I have dimensioned everything. Then you move on to this. Dimension the overall object if needed. So it could be that after you've done all those features, you've actually got enough information so that you know the overall size. So we'll go back to this like goofy looking statue. Okay, the overall dimensions would be the overall height, the overall width, and the overall depth. But after you've dimensioned other parts of it, you might already have that done. If it is, and then we move on to the next one, every view has greater than or equal to 1 dimension. So what that means is that you don't have extra views. If all your views have a dimension, then you're done. If you have a view that doesn't have a dimension on it, then you actually delete that view. So here's what that means. I'll kind of come over here to the left. You know, you have your isometric, you have your top, you have your front, and you have your right-hand side. After you do all the dimensioning, if you look at the right-hand side and you did not dimension anything on the right-hand side, then you are going to delete that view. What that means is that that view was not necessary in order to design your object and convey all of the necessary information. So engineers are all about giving you all the necessary information, but we're not about giving you extra stuff, because extra stuff just makes it harder to sort out the important stuff from the not important stuff. We don't want to duplicate stuff. And so when you are finished, if you do have a view that does not have any dimension on it, then you would delete that view. Now up at the top here, this is like super important stuff. So these are the guidelines, okay? First one, match the dimension precision to the measurement precision. We haven't really talked about that. What that means is that the precision, like how many decimal places you carry out your dimensions, matches what you have for your measurements. So only dimension a view that accurately shows a feature. So that kind of goes back to the circle thing. Like you wouldn't put the dimension for a feature on a view that you couldn't really see it well. If you think back to the last lesson, we had a view where like the top of a hole was underneath an object line. We had like a hidden line under an object line. Like you're not going to dimension stuff from a view like that. Never dimension to a hidden line. When I took my training class a couple summers ago, they said this was like a huge issue for students. So when you're dimensioning, if you have one of those dashed lines, okay, you should never be drawing a dimension to a line that's hidden from that view. You've got to go find the view where that line is not hidden, and that's where you're going to put your dimension in. So no dimensioning to hidden lines, okay? If you need to like highlight that on your PowerPoint or something to remind you of it. Now, the next two, this can get tricky. The first one, number 4, is do not underdimension. You have to put on your multi-view all of the dimensions that are necessary for somebody to be able to build your design. Don't leave stuff out. You can get to a part in design, like I have no idea how big this should be. So sometimes our temptation is to say, okay, fine then, I will dimension everything. But that's going to violate guideline number 5, which is do not over dimension. So you do not put extra dimensions onto an object just because you're afraid of under dimensioning. What that means is that you have to think about this process. You really have to think, do I have everything and do I have anything extra, and catch it from both of those extremes. Here's a common thing that people might do. So suppose you have something like this and you have a circle, okay? And you dimension from, we'll put like the little center mark on here, okay? And so you dimension from here to here, and like that's 2 inches. And then you dimension from here to here, and this is 2 inches, okay? What you don't need to do is say, okay, that's 4 inches. Because you already have that information given when you positioned the circle in there. So you already gave that dimension of 4 when you did that. You could do this where you, oh, I deleted my whole circle there and it's gone. My whole rectangle is all gone. Okay, we'll put it back. You could do 2 inches and then the 4 inches, and then that would tell you that the other dimension was 2. But you want to be really careful of that. You don't want to give duplicate information on on your view, and you don't want to duplicate information from, like, say, the top view to the front view to the right view. So if you give the depth of the object from the top, you don't need to give the depth of the object from the right. That would be giving the same dimension twice, just on two different pieces of the diagram. It can be tricky. It requires you to think. Do not cross your dimension lines. This can get tricky. So if you had like a little circle and a big circle there, actually that's probably a bad oh, okay, I can do this. This is I don't want to do it in that color though. So if you do this and you say, okay, the diameter of the circle is 1 inch, and you have like your dimension lines there, okay? And then you do the small circle, like you would not want the lines from the small circle to like cross right over where you did the dimension for the big circle, and then you have like the little circle is like 0.5 inches or something up there. That's just like super messy. So you want to try to take like the bigger, larger dimensions and you put those further away from the object so that the smaller ones will nest inside, and you're not doing like the big one first and then the small ones are crossing over it. It has to do with the positioning of those dimension lines so that they're not crisscrossing each other. It says leave a gap. It's like weird because they have like a lot of do nots, but leave a gap between extension lines and object lines. That means don't put like you have like your extension lines here, and you don't put your measurement like right there so it's right next to the object line. You do want enough space between an object line and the extension line so that like you're not conflating the two. And then 8, avoid crossing the leader lines. So if you've got a leader line for your diameter, instead you don't want to cross like the leader line with another leader line or extension line. I think you guys get the idea. There's a couple of other things that I think I've mentioned. You don't put the dimensions on the drawing itself. So you're always going to take those dimensions off the drawing, and it can get tricky. You can be dimensioning something and you think of all these guidelines and you think, well, where am I going to put these dimensions? Like there's just too many of them. And sometimes that does happen. You have too many of these lines, and sometimes you actually need to do more than one multi-view so that you'll put some of the dimensions on one and some of the dimensions on the other. We're not going to start with anything that complicated that you would have that many dimensions. All right, let's take a look at this. These are just some examples, and I do want to point some other things out here. Notice that this is our isometric, like up in the corner here, and then you have your top view and you have your front view. Notice that there is no right view, and that's true for both of them. That's because there wasn't enough information. Like the right view for both of these is basically a rectangle with like what the depth of the object and then the height. But if you look at that, the depth was given here on the top and the height is provided on the front view right here. And so there wasn't any additional information to put on the right hand side, and so that is gone. I want you to note a couple other things about this. That's not what I meant to do. Clean this up. Notice where the dimensions are written. We generally want to put all of our dimensions inside the diagram. So you want them in between, like the top view and the isometric, in between the top and the front, in between the front and the right, and in between the right and the isometric. You want them in this space here. Now, sometimes you can't do that. You can't actually get all your dimensions located in there. So what we were told in our training, because I had never I was electrical engineering, so I didn't have to do lots of CAD drawings and manufacture stuff. That's just not like I was building circuits when I was in college. So it's a whole different kind of diagram. Like they have their own set of diagrams. But sometimes you can't fit it. So what we were told is you try everything you can do to get those dimensions located on the inside, but there will be some times when you won't be able to do it. And so if you look at this one on the right here, we have a hole. The hole is located towards the bottom here, And the place to dimension this that makes sense is to dimension it coming out here. If you try to go up, you start running into, well, first of all, you're going to cross the leader line through the entire drawing there. So we're trying not to clutter it up too much. And then if you try to move this over here, there's too much other stuff going on over here and it just gets too crowded. So what we were told is you try everything you can to get those dimensions on the inside. But if you have to dimension something on the exterior, so these out here, like they're on the exterior part of the drawing, that you are just able to justify it and explain why you made that decision. So yes, I know I'm not supposed to have measurements out here, but here's why I did it. Because if I tried to move it, I would have issues. Notice that the circle is dimensioned on the view that shows the circle. So you might be tempted to do this. You might be tempted to say, well, I could put it on the inside if I dimensioned it up here. But remember, one of our rules is you don't dimension to a hidden line. So you can't actually see the hole from the top view. We know it's there, but we can't actually see it. And so you can't dimension it. You have to dimension the diameter from the view that shows where the circle actually is. Okay, so this is a class activity. As a class, dimension the object shown using the dimensioning flowchart and identify an example of each type. So what I'm going to do is I'm going to stop this instructional video here and give you some time to look at that, to give it your best shot, see what you can do. We have a scale there. It looks like that distance from my computer, it looks like 2 blocks equals 1 inch. And so look at all of this, look at your features, try it, do it in pencil, and then we will go over it as a class. And then of course, we're gonna start dimensioning some stuff on your own, and then we will learn how to dimension in Fusion 360.